Hey guys, welcome back to our YouTube channel where we teach you AP Chemistry. You're here with Mahleej and Janiya. Let's unlock the secrets of chemistry one molecule at a time.
Electrons in the outer shell are the stars of the show because they control how atoms react, bond, and exist in the world around us. Valence electrons are the electrons located in the outermost energy level of an atom. These electrons are the most important electrons in chemistry because they are the ones that interact with other atoms. Inner electrons stay close to the nucleus and do not usually participate in chemical reactions. When atoms form bonds, only the valence electrons are involved. This means that if we understand valence electrons, we can understand why atoms bond, which atoms react easily, and which atoms almost never react. Valence electrons are the key to predicting chemical behavior. The periodic table is organized in a way that helps us easily find the number of valence electrons for most elements. The column, also called the group, tells us how many valence electrons an element has. For example, elements in group 1 have 1 valence electron, elements in group 2 have 2 valence electrons, and elements in group 17 have 7 valence electrons. Elements in group 18, known as the noble gases, have full outer shells with 8 valence electrons. The row or period tells us how many electron shells the atom has. An element in the third row has 3 electron shells, but only the electrons in the outermost shell count as valence electrons. At this point, you can point to the periodic table and trace across a row and down a column. Valence electrons matter because atoms tend to be most stable when their outer shell is full. For many elements, a full outer shell means having 8 valence electrons, which is known as the octet rule. Elements with a full outer shell, such as neon or argon, are very stable and rarely react. That is why noble gases are often described as unreactive. Elements with only 1 or 2 valence electrons, such as lithium or sodium, are very reactive because it is easier for them to lose electrons than to gain many. On the other hand, elements with 7 valence electrons, such as fluorine or chlorine, are very reactive because they strongly want to gain 1 more electron to fill their outer shell. By knowing the number of valence electrons, we can predict how an atom will react with other atoms. Atoms with few valence electrons tend to lose electrons, while atoms with many valence electrons tend to gain electrons. This predictable behavior explains why certain elements form bonds with each other over and over again. Valence electrons provide the connection between the periodic table and chemical bonding. Without understanding valence electrons, chemistry would feel random. With them, patterns begin to make sense. Valence electrons explain why elements behave the way they do, why the periodic table is organized the way it is, and how atoms prepare to form compounds. Next, we will see how valence electrons lead directly to the formation of ionic compounds.